Good evening, friends. The topic for today's session is how to deal with higher order construct and how to check the validity of a higher order CFA and how to use higher order construct in the structural equation modeling. So we will discuss some exercise also with examples, and I hope after today's session you will have thorough clarity about higher order constructs. So the session will focus on the three aspects: dealing with higher order construct, higher order CFA, higher order SEM, and we will learn each and everything with examples. Now, the first problem which I face in the understanding of the construct. So in this case, this is a just prototype. This is a zero order construct, and it is measured by three statements. This is another zero order construct measured by three statements. This is also a zero order construct measured by three statements, and all the three zero order construct is known as first order. So the combination of zero order is a first order. Now these three zero order construct, they are measuring the second order construct. They are measuring the second order construct. And second order construct is not measured by the statements, it is measured by the other zero order construct. So in this way, we will use the second order construct. And in this example, the intention to purchase travel online, right? So it is measured by three constructs. So in this case, perceived complexity is a construct, zero order construct, because it is simply measured by the items and we are testing its impact on this. So how this model is different? The model is different in that the perceived relative advantages is a second order construct. It is measured by 5 zero order construct. In this case, convenience, financial advantage, time saving, enjoyment, product variety, these are the higher order constructs. Second order construct. So this is a second order construct. So let me show you now. Before moving to this side, just see some of the higher order construct. Risk. So it is a second order construct. It is measured by 5 zero order construct, and these 5 zero order construct is measured by these 5. So in the models, we are using this is the one of the good example. If you see, work stress is measured by 5 type of stress, and all these 5 type of stress are zero order measured by the items, but work stress is not measured by the items. Work stress is measured by the constructs, zero order constructs. Similarly, work life balance is measured by 4 zero order constructs. And organization climate is simply simple zero order construct. So we are not measuring. It is simple zero order construct. It is not a second order construct. So in this diagram, we are having the work stress and work life balance as second order construct and organization climate at zero order construct. Now this is this example we will do in the exercise, and in this example which we also do today, the financial literacy is measured by 3 constructs. Financial knowledge, which is a single item construct. Financial attitude is a zero order construct, and all the three are measuring financial literacy, and it is formative. So we are basically frequently using this second order construct, and in some cases I am also using the third order construct. So nowadays first order and second order and zero order are very common. Before moving to the example, I'm giving you one more example to just make more clarity. Okay, so I am giving you one example. Okay, so this is emotional intelligence. So EI means emotional intelligence. Now, those who are in HR and OB, if I ask them how this emotional intelligence is measuring, so emotional intelligence is measured by two constructs. Okay. So this is personal intelligence. PI means personal intelligence, how much you are intelligent in personal behavior. And second is social intelligence. Okay. Now, personal intelligence is measured by three aspects. And these are also the construct. These are also the construct. And social intelligence is measured by two constructs. And all reflective. So this is self-awareness. This is self realization, or then self-control. And these are measured by items. Social intelligence is measured by social skills and social behavior. Now, can you tell me which emotional intelligence here is a which order construct? So the answer is it is a third order construct. Personal intelligence is a second order construct. Social intelligence is a second order construct. And these are all individually zero order. So I hope by this example, you can understand that what is a third order construct, what is a second order construct, and what are the zero order construct. So I assume that you have more clarity on the orders. So one thing which is very important here, personal intelligence is not measured by the statements, it is measured by the three constructs. Social intelligence is not measured by the statements, it is measured by the two constructs. Emotional intelligence is not measured by items, it is measured by these two constructs. So in this way, we can define the higher order construct. Okay, so after this example, I assume that you have some clarity on the order of constructs. Okay, so now we are coming to the beginning. We divide higher order construct into four types. There are four types of higher order construct. Okay, now you can see this diagram. So this is called the reflective construct at item level. You can see it is reflective at item level and reflective at construct level. So there are two levels here, item level and construct level. Item level is reflective, construct level is also reflective. So it is called reflective construct. Reflective construct. Now let's see this. This is reflective at item level, but formative at construct level. So it is known as reflective formative construct. reflective formative construct. It is a type 2 construct. So it is a type 1 and it is type 2. So type 1 means reflective, reflective, formative. Now type 3. So you can see that it is formative at item level and reflective at construct level. So it is called reflective, no, formative, reflective. First, we call the nature of the item level. Then we look at the construct level. So it is formative, reflective. So it is formative, reflective. In this case, it is formative, 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 formative. So we divide the higher order construct into 4 types: the reflective, formative, reflective, and reformative, formative. And the question is that how to decide? How to decide that which construct is reflective formative, which is formative formative, and I'm simply telling you this knowledge is coming from the literature. You cannot decide on your own that let's take this construct as a formative, reflective, formative. No. The support should come from the literature because it is a theory. Construct is a theory. The knowledge comes from the literature support. I hope it is clear now. So I'm giving you some examples. So it is a reflective type. So in this case, this SO is measured by FO1, FO2, FO3, first order 1, first order 2, first order 3, second order, SO is second order. So when we combine 0 order, it is basically becomes first order. And it is measured by 3 items. It is measured by 3 items. It is measured by 3 items. So it is a reflective. It is a reflective construct. And the example of, okay, second is the for reflective formative. Now, if you check the financial literacy in practical, financial literacy is measured by 3 constructs. All the 3 are 0 order. And the nature is reflective formative. At item level, it is reflective. At construct level, it is formative. So we call it reflective formative type 2 construct. You can see a risk. Risk is a second order construct. At item level, it is reflective. At this level, it is formative. So it is known as the reflective formative construct. Now, similarly, if you check this, firm performance. So firm performance is a formative, reflective. At item level, it is formative. At item level, it is formative because direction of the arrow is like this. And it is reflective. So we call it formative, reflective. And the last is formative. And if you ask my experience, I have seen so many reflective. So if I work with 100 models, 80% of them are reflective. 18% of them are reflective, formative. And hardly 1 or 2 I found which are formative or formative, reflective. So they are very rare. So these 2 categories are very rare in the literature. But possibility is there. So we divide the construct into 4 types: reflective, formative, reflective, and formative. So we call them type 1, 2, 3, 4. Now, how to deal with it? The most popular approach we can use is repeated indicator approach. So what is repeated indicator approach? Actually, in AMOS, the way of dealing with higher order construct is entirely different. And the way of dealing with higher order construct in SMARTPLS is entirely different. The most popular approach in dealing with higher order construct is repeated indicator approach. Now, in repeated indicator approach, all the indicators are repeated in the second order. So all these are individuals, zero order. So all the indicators are repeated in the second order. So all the indicators, all these statements are reused again, repeated in second order. So in the repeated indicator approach, the manifest indicator means all the indicators of the first order construct. So in total, we call it first order. And all the items of the first order are repeated in the second order. So it is called repeated indicator approach. This procedure to model second order construct with PLS is based on the hierarchical component approach suggested by Volt. So this is the simplest way to deal with the second order construct. Now, what mistake the scholars do in doing this? Number one, because we are using every item twice, and suppose you are using it third order, then thrice. So for a second order, every item is repeated twice. In third order, it is repeated thrice, 3 times. So what happens? The level of multicollinearity shoots up. Because obviously, when you repeat same item many times, the level of multicollinearity is moving up. Second, if you cannot calculate the CR and AVE of this model from the software, you have to estimate by using your own manual calculation. And I will show you that how we can calculate. Because software will give you the problematic values. I found that if you take the CR and AV values from the software, so they are always coming problematic. So we don't take those values, we calculate these values from a manual calculation. And how we can calculate, I will show you. So these two problems are coming by default from this model. So we have to deal it with in a different way. Now, in the repeated indicator approach, these are the examples. So one thing which you have to keep in your mind, that if the item levels are formative, the repeated indicators are formative. So you can see that at item level, it is formative. The indicators repeated are formative. And if item level are reflective, then indicators are reflective. In this case, you can see these zero order are reflective. At item level, it is reflective. So in repeated indicator are reflective by default. Even if this is formative, at construct level, it is formative. But when we repeat the items, we consider the approach in item level. So item level are reflective. So we take the reflective here by default. Similarly, if item level are formative, all this will be formative. All the repeated item will be formative. Formative, formative. So this is one confusion which most of these scholars may have in the mind. So they say that it is reflective, so we can keep it reflective. No. Whether to take repeated items formative or reflective, you have to check the item level. Whether the item level are reflective, then you can take it reflective. When item level are formative, you can take it formative. Construct level, we never see in this part. So this is the most common mistake I found in the caller. Okay, like in this case, This is reflective, item level is reflective. So we take the indicator approach reflective. And it is reflective, formative, but when we repeat it, we will follow this rule because the item level are reflective. So we can take it reflective. So this is the common concept we have to check. And one more thing which I want to tell you, if the construct, second order construct is formative, there is no need to calculate the AVE and CR. And there is also no need to check the discriminant validity for this also. So for a formative construct, there is no requirement for calculating the construct loadings and the composite reliability and the average variance expected because it is formative. These conditions are not applicable on the formative. So you will calculate CR and AVE only when you are having repeated construct. So when the second order is repeated, then only you can calculate construct loading, composite reliability, and average variance expected. For a formative, no requirement. And actually, the problem comes when the scholar come to me and say that, sir, we are using formative, but CR value is not coming. Obviously, it will not come. So you have to understand that. Or the problem happens when the guide say that now leke aao formative mein to aur dikkat hai. So it is then it is a big problem. When panel members say that your ACR is less than 0.7, AV is less than 0.5, irrespective you are using the formative, so you have to keep all these things in mind. Now, so how to check the validity of a second order construct? It is a different way. Don't see the values given by the software because I found that in most of the cases it is wrong. So all the zero order construct must be significantly influences the second order, number one. This is condition, but all these conditions are for reflective. All the zero order construct must be significantly influence the second order. Have high correlation with other construct. Composite reliability more than 0.7. AVE more than 0.5. These are the conditions. So let me add one more thing here. Second order, reflective. Because these conditions are not applicable for formative at any level. Even at if the you are using the formative reflective, then CR and AV are required, but at item level it is not required. Now, when you use a second order construct, like this is a second order construct, and we are using the repeated indicator approach. So it is a work stress construct. It is measured by professional stress, reward stress, conflict mediating stress, task stress, role-based stress. And it is reflective because it is reflective at item level. So we take the repeated as item level. All the value should have the average of more than 0.7 in a reflective. So whenever you check it, you please check it. All the path coefficients are greater than 0.7. And if some path coefficient is less than 0.06, so average should be more than 0.7. So exactly, they are not path coefficient, they are called construct loading, but at second order level. So the exact name is construct loadings. So these are the construct loading of the outer side, item side. Okay. So you have to check the composite reliability of this construct, multi-collinearity, AVE, and we are using the repeated indicator approach. Okay. So this is the theoretical background. And whenever you use the higher order SEM, higher order construct in the SEM, you have to display like that. Like in this case, work-life balance is second order, work stress is second order, and it is reflective. By default, most of the constructs are reflective, and the hypotheses are this and this. So there are two hypotheses in this model. So now I am showing you how to draw this model. So first of all, I will show you how we can calculate the construct loading multicollinearity AVCR of a second order constructs. It means is it how to check second order CFA, and then I will show you how to make the second order model. So we are going to do this exercise, and while doing the exercise on the SMARTPLS, I will try to show you step by step how we can do that. Okay. So we are using this data set, the higher order data, and let me show you the data set. So meanwhile, open the SMARTPLS also. Okay, so I'm opening a new project, putting 2 here so that we can see on the top, and it is higher order, import data file. So we are using this is the data, and so this is the data, import it. Now we are going to create the model. So first of all, I am selecting the CFA second order. Okay. Now work stress. If I show you the diagram, the work stress is second order, and I am showing you how to check the validity of this second order construct. So TBS, this is task based stress. And I'm hiding the items. Okay, then role based stress. Then we have CMS, conflict mediation stress. Then reward and recognition stress. And finally, PIS, performance. Okay, so this is professional stress, reward and so these are the 5, and they are representing the work stress. Okay. Now let me show you the complete model, and I am putting in this way just to show you the indicators also. Okay. The reason of showing you the indicator is that so that you can also check we are repeating the indicators, and some adjustment you have to do like this. So we are sending to the left. So now I think you can see all the items clearly. So what I am doing, I'm just repeating the indicators. So again, I will select all the indicators once again. And one thing you can see that if I am selecting this selection will also, it is also visible here. So I can check which item is selected and which item is not selected. So now you can see that all the items are selected. Now let's take here. And it is called work stress. So basically we are repeating the items in second order. So I am putting in one page so you can see the all values clearly. Now it is completely visible. So after that, let's connect. It is reflective, so we can connect like this. If it is formative, then there is no need to check the validity, but it is reflective, so we have to check the reliability and validity. The model is complete. This model is known as second order construct using the repeated indicator approach. And after that, we are just going to apply bootstrap. The mistake the scholars are doing that they are applying the consistent PLS. But here consistent PLS will give you the problematic result. Now, if you check the construct reliability and validity, the problem is there. The Cronberg alpha is good, composite reliability is good. In 90% of the cases, AV is coming problem. So scholars are now worried that why this problem is coming and how it is solved. So according to me, this method is wrong. We should calculate it manually. But what other things you can check is collinearity level. So, and because we are using one item two times, so you can check first time it is okay and second time problem. So you have to check only the first value. Like PS1, first value is okay, no problem. PS2, PS2, so both values you are looking at, they are showing problem, right? But the first value is 0.3.08, it is just on the borderline. Because in repeated indicator approach, the VIF is calculated two times. First value is RRS, like for example, in this case, RRS2 is 3.2, RRS is 2.8. So one value is okay, and second value is problem. So if one value is okay, no problem at all. And this is a basic problem which comes in the repeated indicator approach because you are using the same item two times. So the second value sometimes show you the higher value which you have to ignore. And you can do also one thing, you can click on the inner model always, collinearity, and always two value will come. And the problem comes when you are using the third order level. Every item come three times. Then there is a big problem that first value is okay, all other values are problematic. So you have to check that. Okay, now we are moving to construct loadings, outer loadings. And outer loadings, you have to check again, you have to check the outer loading comes two times again. CMS1 is one loading is for CMS. And the second loading is for work stress. So here I just want to say you that only check the loading to the construct, not the second order construct. Because CMS, it is an item, it is attached to the its own construct and the second order construct. So you have to ignore the second order construct because its value always comes less. And there is no need to check this. Only you need to check is the construct loading between the item and its construct. So this is again a confusion which is coming in the second order construct. So the solution is that you only need to report the select CMS only to the CMS, not to the work stress. I hope it is clear. Then the next thing which we have to do, like for example, this table is important. I am taking to the Excel and opening a new Excel file. So when we copy it, so you can see that the work stress, all item loadings to the work stress should be deleted. So you simply do one thing, you just delete all these items which are linked to the work stress like this. So these are the outer loadings, and all the outer loadings are greater than 0.7. So there is no problem in this part. So this you have to report. Second thing which we need to report, and here also you can do one thing. This is the construct name. Construct name is like CMS, and we can repeat this command by Control E command. Okay, so this is the name of the construct, and you can also take it only one. So these are the TBS. This is the construct, and we have to report two more things. One is the composite liability, and second is AVE. So how to calculate CR and AV, I am now going to show you. So go back, go apply bootstrap and start calculation. Now you are getting the values of inner model 0.7, 0.701, 0.7. So we have all these values, and let me check once again. Let's apply this. Yeah. So let's stick to this part. We are having the path coefficient. The path coefficient of CMS is 0.789. PIS is 0.868. And I am taking all the path coefficient to the Excel file. So CMS, PIS, RBS, RRS, TBS. So we can remove this part. Now you have to check see the calculation slide carefully. And I am transposing it. So we have these values. Okay. This is name of the construct, and this is the name of basically it is called construct loading. So we have calculated these two things. Now we have to calculate one more thing, the loading square. Loading square. So it is simply the square of the loading. So this is the square of the loading. And then you have to calculate the error. So the error is equal to 1 minus loading square. 1 minus loading square. So you have to calculate the error term. And all the error must be less than 0.5. So you have three values: loading, loading square, and the error term. Now take the total. So it is sum of this. So let's carry forward. So we can calculate the sum like that. And taking the 3 decimal here. Now from these values, so I can calculate the CR and AV of the complete model. So this is the CR and it is AVE. So I'm calculating for the task work stress as a complete construct. So CR is calculated. Let me write the formula here. This is for your knowledge. The CR is calculated. It is sum of the lambda square upon, or I will, so it is not properly coming. So formula I also shown you in the session 3. So I can show you the formula from there. So these two are the formulas for CR and AV. This lambda is construct loading and 1 minus lambda square is the error. So I am going to use these two formulae. So let me take these two formulae in the today PPT. So because I already remember the formula, so I'm just applying. It is first value is this square of the sum of the loading divided by a square of the sum plus the sum of the error term. So this is the formula for calculation of the CR, and your CR value is 0.912, and the AV value is this divided by and simply this plus 1.6, and this is your AV value. Now, what is the benefit of calculating this? I hope you can understand that why we have done this. Because if you check the value of the AVE from the software, I don't know why software is not giving you the correct value. Software is giving you the wrong value. So this part of the calculation is wrong coming in the software. That's why we have to follow this procedure. And now you can say the work stress is having the CR of 0.913, AV is 0.677, so it is perfectly fine. Okay. If I show you this value is 394. And because of this, we always have a confusion that how to solve this problem. The correct way of solving this problem is this. Okay, I'm showing you one more thing because somebody is saying that let's apply consistent PLS bootstrapping, but I don't think it will solve my problem. So let's try to apply this also. It is just nothing. It is applying the consistent PLS on the bootstrap data, nothing else. So software is applying the bootstrap procedure and then calculating all the values. But still, I expect the problem in AVE. So we don't have even the value. We're getting the path coefficient, total effect, outer loading, setting, path. Okay, so even this method is not giving me the required values. Let me check one more time. Because when you apply, you have two options, slower. So in slower, you will get all the values. It will take some time to calculate. When you run the faster bootstrap, you will get only limited values. When you run complete bootstrap, you get other values also. So I think we are getting in the other complete bootstrap. So then we will get all the CR and AV values. But it is taking time because it is a bootstrap procedure. So we have to wait for the result. The why I'm showing you this exercise, because I believe that this exercise will not solve your problem. You have to do it manually. Whenever you are dealing with the higher order construct, we did a lot of mistakes. Actually, 90% of the scholars are committing the different type of mistakes. So that's why I am showing you step by step that what mistake you are doing and what is the correct method of calculations for second order construct. So now we are getting the result and we are getting the value of AV, and still you can see that the AV value is problematic, 395, 395. So the point which I want to put here, the correct method of calculation of the AV for the work stress is the way which I calculated. The software is always giving you the problem wrong value, and because of that, the scholars always worry that why I'm getting low AV despite the fact I'm getting all good values. So this is the correct way is but doing by manual calculation. Okay, now the next point, I hope you know how to calculate the validity of a second order construct. And but at the level of the zero order, you can take a CR and AV values from here. That is not a problem. So if you click on this, copy to Excel and paste here. So these values you can put, like if you want to put Cronbach, alpha. For individual, for CMS, it is 0.987. So you can take all the values, but when you take for the work stress, in fact, you have to put the second order construct here, and okay, then the name is work stress. So for work stress, ACR and AV you have to calculate by this method. So I am sure that you now have clarity on calculation of all these things. So now moving to the SAM. One more thing we always prefer to do here, go to calculate, simply apply PLSM, and we can also calculate the values in the latent variable. This is a latent variable. I just copy to the Excel. So how it will give benefit to me that in your data set, you can calculate the score and paste it. So now I can paste the values here. So we have the score of all the construct, and I'm saving it. Now I'm showing you how to use the SAM model. So save it, go back. Okay. Now we can do one more thing. We can import a new data sub file. I'm just taking a new project. It is putting 3 higher order SAM. The reason is that I want to use another data set. Or if you don't want to do that, you have to delete it, delete resource, and now taking the modified data, higher order data. So for that, we have to save the data first. Save it, taking the same data set. The benefit is that is now we are having the modified, the construct scores. Or I'm copying this model, duplicate. So we have a duplicate option here. Now we are running the SAM second order. Okay. So same model I can open without any problem. The benefit I have is that I can take the second order construct in this way also. This is the work underscore stress. So the second order construct can be represented by 2 methods. This is the original method, and I normally prefer this method. But you have also a second shortcut method. So it is also a work stress measured by the items, and it is also a work stress measured by the constructs. So you can also use this in the SAM, and you can also use this in the SAM. So we are not using it. Now I am hiding it. Now the reason is that I am going to convert into a SAM. My independent variable I'm taking here, this is the work organization climate, and I'm putting the organization climate here, and taking the item to the top, connecting them. So now it becomes a SAM. Similarly, I can take my another construct. So just doing fast. It is called work-life balance. So hiding the indicators because managing all the items is not easy. So let's take the items, hide the items. So we are having the four construct measuring the work-life balance. Okay, hide indicators, and hide indicators. Because it is a second order, so I have to use the repeated indicator approach once again. So taking the all the items once more time, and it is work-life stress, work-life balance, and I'm using the repeated indicator approach, connecting the hypothesis. So after this is my second order SAM, and I will examine the hypothesis by going for the bootstrap procedure. And by applying the bootstrap procedure, it will take a lot of time because we are using two order construct here, but doing it very easy. So just see the result, and after that, the session is over. So I'm just reducing the sample size, otherwise it will take a lot of time. Now it is moving fast. So I run the model, and both the values, these values, let me show you clearly. So this value is significant. So work stress is negatively influenced by the organization climate. If organization climate is good, work stress is less. And work stress is also influencing negative to the work-life balance. High stress, low work-life balance, and low work stress, high work-life balance. So in this way, we can check the uh, second order construct, and you have to report the model like this. In second order construct, usually we hide the indicators because many times it is very difficult to show all the indicators along with the model. So normally we hide the indicators in designing second order SAM or second order model. Yeah. So this is the second order SAM. So I'm just showing you one graph which I was designing for somebody. Yeah. If I show you this model, so now just asking you, which is this model? Second order, third order. In this case, this is a third order construct. And if I show you the indicators, so there's a lot of indicators. And show indicators, show indicators. So it is a third order construct. All the items are repeated here. All the items are repeated here. And all the items are repeated here also. So every item is coming three times in a third order. So sometimes we are also using the third order constructs, and in third order construct, we are repeating the item three times. So I'm also putting this value. in PPT so that you can also see how we can also put the third order. So I hope that today's session will give you more clarity about how to deal with the higher order construct. And in case of any confusion, we can discuss now. So that's it from my side about the second order constructs. And we are using the higher order construct frequently nowadays. It is very, very common. And you must know how to do it.